Hi guys. So today we're going to look at some properties of logs. So what this is going to do is allow us to rewrite logs into some different forms. This is going to make it easier for us to simplify, and it's going to be really helpful for us when we get to solving next week. So what we're going to start to do is we're going to start by condensing logs, multiple logs, into just one single log. So these involve a few properties. Now these properties are actually kind of similar to your exponent properties. So think about your exponent properties. If I had x squared times x to the third, even though it was x squared times x to the third, I added the exponents. If I had division, if I had x to the fifth divided by x to the third, I subtracted the exponents. Well, those follow similar properties with logs. If you have multiplication in the argument of the log, you can separate those into two logs that are being added. Same thing if you have two logs that are added, you can combine them by multiplying those arguments together. All right, if you have division in the argument, you can separate that into two logs that are subtracted. And then the last one, the power property. Okay, think about if you have x to the second to the third power. Well, then you multiplied those exponents. Well, same thing. If you have an argument raised to a power, you can move that exponent to the front and multiply it by the log. So let's go ahead and do some examples. We're going to start by condensing. This is going to be really important when we get to solving next week. So in order to condense these, let's look at the operation. So two logs are added. If two logs are added, I can multiply the arguments. So this would become log of a times n. All right, look at the next one. First thing I'm going to do, any number in front becomes the exponent on that argument. So I'm going to start by rewriting this as log 2 to the third, which is 2 times 2 times 2, which is 8. Okay, now if you want to do this in one step, that's great. I'm going to do it in two steps just to kind of break it down. We'll start with these two. Log 9 plus log 8. I would multiply those arguments together. So 9 times 8 is 72. Then I have subtraction. So if I'm subtracting logs, I can divide the arguments. Now again, it's really important. We're just dividing the arguments. We're not dividing the logs. So this is not log 72 divided by log 3. When we condense these, we're writing log one time. Okay, I'm only dividing the argument. So this becomes the log of 72 divided by 3, or 24. All right, let's do a couple more. I'm going to start by moving the exponents first. So 1/2 becomes the exponent. Remember, another way to say x to the 1/2 is square root of x. Move my exponent. This becomes log y squared. Move the exponent. This becomes log z cubed. Okay, so now since there's subtraction, that means I'm going to involve division in my logs. So this is going to be log square root of x is on the top. Y squared is going to move to the bottom. Z to the third is also going to be at the bottom. Basically, anything that comes after a minus is going to be in the bottom of the argument. A couple ways you can look at that. Another way you could rewrite this, you could say this is log square root of x minus, if I factor that out, you'll see that those two things are multiplied in the bottom of the fraction. That's another way that you could look at it. Or again, if you just think about, let's say I have the number 24 divided by 2 divided by 3. Well, 24 divided by 2 is 12. 12 divided by 3 is 4. Okay? That's the same thing as doing 24 divided by 6. So anything that comes after a minus is going to be in the bottom of that argument. All right, now let's look at the last one. Probably one of the biggest mistakes with logs that you need to be really careful about. What everyone wants to do when they see something like this is distribute. You cannot distribute a log to its argument, okay? Do not distribute a log to an argument. The same thing is going to be true with your trig functions, okay? Back when you guys did your trig functions, this will come back up in pre-cal. If you have sine of x plus y, you can't just distribute and say that's sine x plus sine y, okay? You can't do that. It's not multiplied. Okay, distributing works when something's being multiplied. This is not the natural log times a plus b. This is the natural log of a plus b. Okay, the a plus b is part of the ln. ln by itself is not anything. Okay, so we can't distribute. Do not distribute a log to its argument. It can't be done. What can be done, though, because I have a log plus a log, is I can multiply the arguments. So this would become log a plus b times a minus b. And then I'm going to move that exponent. All right, now let me go ahead and actually FOIL it out so it's a little bit neater. That would be difference of squares. It's going to be a squared minus b squared. So now again, I have two logs and there's subtraction. So that means there's going to be division in the argument. So this becomes a squared minus b squared over c squared. All right, so now we're going to go the opposite direction. So we're going to take these logs and we're going to expand them. Now this is going to help us for the next section when we're trying to kind of evaluate these based on some different values and different exponents. So let's start with the subtraction or the division. That's a little bit easier to see. Whenever there's division in the argument, I can separate this into subtraction of multiple logs. All right, now what I also can do is I can take this and expand it farther. Now what you need to be careful of, this is not 7 ln of 5x because both the 5 and the x don't have that exponent of 7. So I can't do that. 5x to the 7th is 5 times x to the 7th, which means this would become the natural log of 5 plus the natural log of x to the 7th. Then I'll go ahead and move that exponent to the front, and I'll be done. All right, let's go to the next one. That uses the same idea, okay? I'm taking the log of all of this. This is 3 times x to the 4th. So where there's multiplication, I'm going to separate that into addition. Then I can take that exponent and I can move it to the front. All right, look at the last one. Next one, I have c written twice. That's okay. So again, I'm going to separate it first where the division is. So this would be log base 3 of 5 minus log base 3 of 12x. And again, that's 12 times x. So I can write this two ways. I can put some parentheses, and then this could be log base 3 of 12 plus log base 3 of x. Or, since both of them are in the bottom, I can make both of them follow a minus. So either one is okay. All right, then looking at the last one. I'm going to start rewriting the square root. Remember, square root is 1/2 as an exponent. Well, that 1/2 can move to the front. And again, on this one, I can move it because both the x minus 1 and the x plus 1 are under that root. They both have that exponent. Well, since they both have that exponent, I either need to use parentheses or I need to distribute it on this last step. So since there's division in the argument, that's going to become subtraction in the logs. The x minus 1 and the x plus 1 are going to stay where they are. There's nothing we can do with that. So this is going to become 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1, or you could just have that 1/2 in parentheses. Whichever one makes more sense to you. So either one of those is okay. Again, we can't distribute that to that argument. The x minus 1 has to stay as that argument. There's nothing we can really do to change it. All right, so we're going to work on expanding some more. And what we're going to do is we're going to evaluate some logs, knowing just a few certain logs. So what I want to do is I want to rewrite log base 3 of 4/5 using log base 3 of 4 and log base 3 of 5. Well, knowing what I know about logs, if there's division in the argument, I can rewrite that as subtraction. So I can rewrite this as log base 3 of 4 minus log base 3 of 5. Well, now what I'm going to do, log base 3 of 4 is equivalent to 1.262. All right, log base 3 of 5 is equivalent to 1.465. So log base 3 of 4/5 I can now evaluate just knowing those two decimals. And I get a negative 0.203. Now again, you may be tempted to just go and plug this into a calculator, okay? Again, I'm going to caution you not to do that. The questions we're about to do, we're going to use the same process, but we're going to use variables instead, so a calculator is not going to help you. It's also important to understand this concept because, again, you're going to need this in your future math classes. All right, let's try the next one. Log base 3 of the square root of 5. Well, square root of 5 is the same thing as 5 to the 1/2. Exponents can move to the front, so this can become 1/2 log base 3 of 5. Log base 3 of 5 is the same thing as 1.465. So this is 1/2 times 1.465, which is 0.7325. All right, the next one's pretty tricky because it's kind of hard to figure out how you get 12 from 5 and 4. And really the answer is we can't. But what I can do is I can use 4 and 3 because 12 is the same thing as 4 times 3. Well, if there's multiplication, I can separate that into addition. Multiplication in the argument becomes, again, addition of the logs. Log base 3 of 4 is in my chart. So log base 3 of 4 is the same thing as 1.262. Log base 3 of 3 isn't listed, but that's one that we could have evaluated last class. 3 to the something power is 3. 3 to the first power is 3. So this becomes 2.262. All right, so like I said, the reason we need to be able to do this without a calculator is because of this concept right here. We're going to work these problems the exact same way, but instead of giving you some random decimal, it's giving you a variable. So let's do log base 3 of 20. Well, let's see how we can get 20 out of 4 and 5. Well, log base 3 of 4 times 5 is the same thing. Multiplication in the argument can separate into addition of logs. So now I can replace log base 3 of 4 is x. Log base 3 of 5 is y. So this whole expression simplifies to x plus y. All right, let's look at the next one. Log base 3 of 64. There's really two ways you could look at this. You could say this is 4 times 4 times 4. So this is log base 3 of 4 plus log base 3 of 4 plus log base 3 of 4. The other way you could do this is the same thing as log base 3 of 4 to the third. Exponent moves to the front. And now, again, I can substitute. Log base 3 of 4 is the same thing as x, so this is 3x. Had you done it the other way, x plus x plus x still would have given you 3x. All right, and then this last one. So log base 3 of 5 over 16. Well, this is the same thing as log base 3 of 5 divided by 4 squared. Or 4 times 4, whichever way you want to do it. Division in the argument becomes subtraction. So log base 3 of 5 minus log base 3 of 4 squared. Move your exponent to the front. And then we can substitute. Log base 3 of 4 is x. Log base 3 of 5 is y. And that's it. Again, it's just reusing those properties and expanding and trying to come up with a way to really write that number in terms of the ones you already know. All right, so we're going to look at two more properties that are a little bit simpler. One of them is the change of base formula. So if you notice on your calculator, you only have regular log and ln. We kind of have to go through that menu to get to log AB. If you didn't have that log AB option, we would have to use this change of base formula a lot more often. But what this allows you to do is take something like log base 3 of 8 and rewrite it using a base of log or a base of ln, or a base of anything you want, really. But typically we use the common log or natural log. So the way it works, when you rewrite it, you take the log of the argument divided by the log of the base. And again, that base can be anything. Typically you'll see log, or typically you'll see ln, but you can use whatever you want. So log base 3 of 8 can be rewritten as log of the argument over the log of the base. Again, it's important to note, this is not the same thing as log of 8 minus log 3. Okay, that's the same thing as log 8/3. Okay, the logs here are being divided, not the argument. So it's not the property we just did. All right, log base 7 of 11. I can rewrite that as log 11 over log 7. And then at this point, you can go ahead and evaluate with the calculator. If you plug this in, and then you plug this in, you're going to get the same value, which is 1.893. Same thing in the next one. Plug in either version, you're going to get 1.232. All right, this next one, same concept, but instead of using common log with base 10, we're going to use natural log, but same idea. Log of the argument divided by the log of the base. Even though I use ln, I'm still going to get the same answer if I plug that into a calculator. And then the last one, this would be ln 20 over ln 2. Again, it's important to note this is not the natural log of 10. Okay, the arguments are not being divided. The entire log is being divided. So we can't do that. But I can go ahead and evaluate this with a calculator and get 4.322. All right, so our last property is the inverse property. So like we talked about, log and exponents are inverses of each other. So one of the things when we talked about exponents that we learned, let's say that f of x is b to the x. And let's say that g of x is log base b of x. Well, if two functions are inverses, we know these are, then if I do composition, f of g of x and g of f of x, those should equal x. So all I'm doing right now is just showing you where this property comes from. All right, so where this comes from, if I were to evaluate f of g of x, I would take the g of x function and replace the x in the f of x function. Same thing going the opposite way, g of f of x, I would replace x with the f of x function. Well, knowing what we know about composition and inverses, since these two functions are inverses, both of these things will equal x. That's where this inverse property comes from. Now, what this inverse property means for you is that you're able to evaluate a couple other logs. So basically, what you need to look for, if you have a base here and a base here that are the same number, that's your answer. If you have a base here and a base here that are the same number, that's your answer. This one's also a little bit easier just because of the properties we just talked about. You can move that exponent to the front. And we talked about this last class. If the base of that exponent and the base and that argument are the same, it's just 1. So that's just x. All right, let's look at some examples. So again, if the base and the base are the same, your answer is just 4. And that's all you got to do. Same thing here, base and this are the same. Your answer is negative 3x. But again, like we talked about, you don't need the inverse property to do that. We can use the property we talked about today, where move the exponent to the front. Log base 7 of 7 is just 1, because 7 to the first power is 7. So that's another way that you could look at that. All right, looking at C. Base, even though it's not listed, the base of ln is e. Those are the same. Your answer is 20. So then the problem is, what do we do when the bases aren't the same? All right, so let's look at this next one. 8 and 2 are not the same, but I can rewrite this in terms of the same base. So I can rewrite this as 2 to the 3 log base 2 of 7. Now the problem is, before I'm done, I can't just say my answer is 7 because of this 3 right here. That 3 becomes the exponent on the 7. So this is really 2 to the log base 2 of 3 to the 7th power, which is 343. So your answer here is 7 to the 3rd, which is 343. All right, now looking at the next one. This one's kind of tricky because you might think, hey, I can't really write 8 in terms of this base. But what you know, log base 4 of 4 is something that you can evaluate because 4 to the something power equals 4. Well, 4 to the first power is 4. Log base 4 of 4 is just 1. So log base 4 of 4 can be replaced with 1. So 8 to the first is just 8. All right, then the last one. Again, the bases are the same, but we got to do something with that 3. That 3 becomes the exponent on the 5. So this becomes 5 to the 3rd is your answer, which is just 125. All right, so those are all your log properties. Again, the condensing is going to come back, especially when we do our solving next week. So make sure you get the practice in on this. So work those practice problems, check your answers, make sure you show your work, especially in that 13 through 18 section. It's really hard to do those if we don't show any work. If you need help on any of those practice problems, again, email me, video request, or Zoom session. And then once you're comfortable, you can take that week 5 check. All right, again, if you have questions, feel free to reach out.